All right, in this video, we're on lesson 2.4, and we're going to be looking at composition of functions, and I'm going to split this up in a couple of videos. I want to look at basic composition where you combine standard functions with addition, subtraction, and multiplication, but then I'm going to do a separate video on composition of functions, which is like f of g of x, g of f of x. Sometimes you'll hear it called FOG or GOF. All right, so we're going to kind of start off slow. All right, so with this problem, it says, or this section right here, it says evaluate each function. Well, to evaluate each function, you're literally substituting in whatever they have in parentheses. So when this says f of 4, I'm substituting 4 in for x. So 3 times 4 minus 5. Well, that's 12 minus 5, which is 7. So f of 4 is 7. For the second one, it says g of negative 7. So we're going to substitute negative 7 in for x. All right. Notice that I'm using parentheses. I did it on the last problem too. Get in the habit of parentheses because that does change things. If you put negative 7 squared in your calculator without parentheses, it's going to tell you negative 49. But really, it's positive 49 plus 9, which is 58. Now, depending on your calculator, you could just put this all in at one time. All right, so for example, if in my calculator, I could put negative 7 squared plus 9, enter, and it told me 58. Okay, so you don't necessarily have to piece it out like I am. All right, it just depends on the type of calculator you have. All right, so for the third example, we have a binomial that we're substituting in. So I would have 2 times x plus 3 minus 5. So I would have to distribute my 2, which would give me 2x plus 6 minus 1. And then I would combine my like terms to get 2x plus 5. In this next example, we're looking for f of 2, so I would substitute 2 in everywhere I see x. So I'm going to have something squared minus 4 times something plus 1, and that 2 is being substituted in. So 2 squared is 4 minus 8 plus 1, all right, which would give me negative 3. Again, you don't necessarily have to piece it out. So I could have done my calculator and said 2 squared minus 4 times 2 plus 1 and still gotten the negative 3. Okay? So however you need to do it is fine. All right? So here we have h of 3, so you can substitute that in. And then you would have 2 times 3 minus 5, which is 6 minus 5, or 1. For this one, we have to substitute in that 2x plus 3. So we have 5 times 2x plus 3, all plus 4. So remember order of operations. We're going to multiply this first. All right, so we're going to have 10x plus 15 plus 4. And so that would give me 10x plus 19. All right. Now that's basic, just substitution. All right. Now we're going to have some examples where it tells me f of x and g of x is equivalent to something. All right. And so when they say f of 5, I have to pay attention. I want to make sure that I'm substituting into the f function. If I have g of negative 2, then I'm substituting into the g function. All right. So the reason why they change the letters is because sometimes you are dealing with real world situations. So like if you were dealing with like profit, expenses, cost, things like that, revenue for a business, then you might have R of X to represent revenue. You might have E of X to represent your expenses, P of X to represent profit, and so on. So that's why those letters change, all right, because they represent something. All right, so for this first example, f of 5, I would use the f function. So I would have 4 times 5 minus 2. And 20 minus 2 is 18. For this next one, g of negative 2, I'm going to use the 3 times negative 2 plus 1, which is negative 6 plus 1, or negative 5. All right, sorry about that. All right, so let me kind of shrink this down a little bit. All right, so I need to see these two functions, so I'm trying to keep those a little bit visual. All right, so here we have f of x plus g of x. Well, what is f of x? It's 4x minus 2. Plus, what is g of x? 3x plus 1. So we're substituting in whatever those values are, okay? And now this is just basic addition, so we combine like terms to get 7x and then minus 1. Now, subtraction is a little bit different, all right? So with this example, we have f of x minus g of x. Well, f of x is 4x minus 2 minus g of x is 3x plus 1. What makes this tricky is I always use parentheses because I need to remember that this minus has to get distributed, because remember, that's like a minus 1. And sometimes when you don't use parentheses, you forget to distribute it. Like you might subtract the 3x, but then you'll forget to subtract the 1. All right, so this is 4x minus 2 minus 3x minus 1, because I'm distributing that negative. So 4x minus 3x is 1x. Negative 2 minus 1 is negative 3. So x minus 3. So if we look at the next example, this one is g of x minus f of x. So this time it's going to be 3x plus 1 minus 4x minus 2. So again, this is like a minus 1, right? So I have to distribute that. So I'm going to keep the 3x plus 1 minus 4x plus 2, because a negative times a negative is a positive. Combine my like terms, so that gives me negative x, or negative 1x. 1 and 2 make 3. The last example is multiplication. All right, so this time they're asking us to multiply. So that would be 4x minus 2 times 3x plus 1. So again, this is just your distribution. So distribute, right, to get 12x squared plus 4x. And then distribute the negative 2 to get negative 6x minus 2. Combine your like terms. So 12x squared minus 2x minus 2. Watch your signs. All right, so those are the first several examples. I'm going to do a separate video that gets into the f of g of x, g of f of x stuff. So you'll notice on your paper that you have some, practice problems. So you'll try those. And then, like I said, the next video is where I'm going to get into the composition.